Hey guys, we are in chapter 10, looking at section 2. We're going to talk about measuring angles and arcs, and this is all within the circle. So let's get started. We have, some good vocabulary words here, and they all stem from circles, and so drawing a circle will be helpful as you take your notes. So, what you want to do is talk about the central angle. A central angle is any angle that is created by the measure of two radii, right? Or by the lengths of two radii emanating from the center of a circle. So right now, I have this angle here. It would be a central angle. So any angle that is formed by radii at the center of a circle, or radiuses, right? I don't know. My Latin isn't that good. All right. So I'm going to highlight that and just call this guy a central angle. And so the arc now is, when I think of an arc, I think of pizza crust. It's like this little bits of pizza crust right here. All right, so that's our arc. Arc is the measure here. So this arc that I'm talking about is also a minor arc. It's a minor arc because it is smaller than a semicircle. And I know I'm getting out of order with my vocabulary, but we all know what a semicircle is. It's half of a circle, and that we'll get there. But this arc is a minor arc because it is smaller than a semicircle. And this arc right here is a major arc. It's a major arc. And that major arc is larger than a semicircle. Generally, I believe, if I'm remembering correctly, that like MN, and let's call this Q out here, you would name this arc MQN, and you would name this arc just MN, to really, emphasize the fact that because otherwise I would just be like, oh, MN, and I wouldn't be like sure which direction to go in. So major arcs, I believe, and I'll confirm as we go through our lesson, would have, MQN. You would name another point on the circle to kind of get a sense that a point that is between M and N on the particular arc. So a semicircle, we know what a semicircle is. A semicircle is going to start, basically, if you think about it, a semicircle would be the arc that is associated with, let me do it this way, the arc that's associated with a diameter, right? So that's a semicircle. Semicircle is half of a circle, and it is a type of arc too. So congruent arcs. Arcs are going to be considered congruent. These little pieces are going to be congruent when the central angle that is associated with it will have the same length. So if I were to say, like, let's say this was a 20, no, let me give a better angle. Let's say this is 60 degrees. This looks like 60 degrees to me. So let's say that's 60 degrees. If I were within the same circle to draw another pair of radii such that their distance was 60 degrees, then I would know that, and let's call this R and S. I would know that the measure of arc RS and R and MN are congruent arcs. They're congruent arcs. And adjacent arcs, let's name this guy T. Adjacent arcs are going to be arcs that are side by side. Arc length and arc measure. I don't see arc measure here. I'm going to talk about it. Arc measure. Arc measure is going to be the same as the central angle. So the arc measure of MN is 60 degrees. The arc measure of RS is 60 degrees. If I were to throw in a random 50 degrees here as the possible value of this central angle, arc TM would be 60 degrees. In fact, the semicircle that we have here has an arc measure of 180 degrees. 180 degrees. Are you guys seeing that? I hope that makes sense. So congruent arcs are arcs that have the same measure and also the same radius length, right? They're going to be, thank you, they're going to be congruent arcs. And all right, so even though the text chooses to take on the arc measure later on in the text, I just thought it was kind of a good thing to know now. So arc measure is always going to be like an angle. It's going to be an angle measure. Okay. Now arc length is a little different. Arc length, it was a lot different actually. Arc length is like, remember my pizza crust analogy? It's like, how long is that pizza crust? Arc length is literally what the measure is of that particular arc. And so we remember that the measure of the entire circle, the length around a circle, is called the circumference. The arc length is going to be a fraction of the circumference. So arc length is given by the formula. I'm tired of this purple. I don't know why I kept it. Arc length is given by the formula, the circumference times the central angle over, let me write the word angle out because that looks like an L, over 360 degrees. Let's think about this for a second. If I took the circle, the entire circumference of the circle, I know I only want piece of it in order to talk about the arc length. The piece that I want is part of the circle. It's part of the circumference. What part is it? Well, let's compare the circumference to, if I do this whole angle turn in here, that's 360 degrees. If I go whoop 360 degrees around, that will be the whole circumference. But if I only want part of the circumference, particularly the part that matches this central angle, I only want 60 out of 360. Does that make sense? I hope it does. So the central angle that is related to that arc divided by 360 times the circumference is going to give me the arc length. We'll see that in a couple of examples. Here in example 1, they want us to find the measure of this angle here. I'm going to use a smaller pen. They want us to find the measure of this angle here, angle X. We know that this whole thing has 360 degrees written all over it, and I need to subtract out the other two. I'm going to subtract 130 plus 90. So the sum of these two subtracted from 360 should give me X degrees, right? Not too bad. Kind of makes a natural sense. So 130 plus 90 is going to give me 220. So I have 220, 360 minus 220 is going to leave me with 140 degrees. And that's the measure of angle X. So here's a little key concept map that comes directly from your textbook. Minor arc, less than 180. The central angle is less than 180. And you see two letters to refer to it. Major arc is the longest arc connecting those 2 points. And you see that they do use 3 letters to represent it. When we choose D, a point that's between A and B inside the major arc. And also a semicircle. I didn't indicate this. A semicircle, you'll use 3 points, right? Or 3 points on the arc to talk about what that arc name is, all right? And the measure of it is 180. The measure of these other arcs would be X. And so I don't know why they don't do arc measure as a specific like definition, but anyway, it's there. So classify arcs and find arc measures. So that's not going to be too hard for us. Let's go ahead. So we see that GJ is a diameter, so that gives us some information. Identify the major arc, minor arc, or semicircle, then find the measure. Okay, we can do this. So here we know just by the naming that this is a minor arc, so I'm just going to jot down minor. And then we look to find the measure, and the measure is the central angle. So the measure of that is going to be the central angle, 122 degrees. And we're done with that one. Let's look at B. B is asking us about GLH. So we're talking about, and let me highlight what we're referring to here. We're talking about this arc that starts there and extends all the way over here. Well, obviously, if the two arcs got together, that whole thing will be 180. So, I'm sorry, 360, my bad. So obviously we know that we're going to do a little bit of subtraction. But first, let me answer the first question. We have a major arc here, right? And we can tell just by the 3 letters that are used to indicate the arc. And then secondly, we need to calculate. I keep wanting to write 180, but it's 360. 360 minus 122, which is going to be 238. I think I'm doing that right. You can let me know. I'm sure you guys will be like, you're wrong. So let's take a look at this last one, GLJ. And GLJ is clearly a semicircle. And because it's a semicircle, we know that its measure is 180 degrees. So that arc measures 180. This arc measures 238 degrees. And this one here, that's a terrible arrow, this one here is 122. So this theorem that gave us that definition we talked about earlier, in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So 1 and 2, angles 1 and 2 have to be the same in order for FG and HJ to be the same length, to have that same, to be congruent, to have the same length. Yeah. All right, so let's take a look at example 3. We're going to refer to the circle graph to find the measure of each thing. So we see here female participation in sports is the chart, and we want to find the arc measure of CD. So since the arc measure is CD, we're talking really about the central angle, right? Not the arc length. We haven't gotten to that yet. So what is this angle value here? Here's how I would do it. The reality is, if you're dealing with a percentage chart, the entire chart is going to be 100%. But we also know that that 100% is the same as talking about 360 degrees, right? Does that kind of make sense in your mind if you're thinking about this? So 100% means 360 degrees. The question is, what does 18% refer to? Right? This reminds me of a really neat proportion we could write. So we could say 18 is to 100, and I should have this as percentages. 18 is to 100% as X is to 360 60 degrees. Yeah? Are you guys with me? I thought I just messed up in my brain. I was like, what are you saying? You are speaking Greek. So if you don't understand and I don't understand, we're both on the same page. But I think I understand. Let's try it again. 18% to the whole 100% is the same as whatever this central angle is to the entire 360 degrees. We know how to solve these problems. We cross multiply and then we divide to get our answer. So making this calculator ready, if you're going to use a calculator, you would do 360 times 18, which is equal to 100x. So then to get x, you would say 360 times 18 divided by 100 will give you your value. So from my calculations, I'm getting that x degree, or the central angle here for volleyball, CD, is going to be 64.8 degrees. So that's what the measure of that arc is. The measure of the arc is going to be the same as the central angle, 64.8 degrees. Now we're going to check out the measure of BC. Do I have another one? Okay, we're going to think about the measure of BC. Oh, well, BC is going to be the same thing, right? If we're talking about 18% and BC is 18%, that means this central angle has to be 64.8 degrees, and therefore the arc measure is 64.8 degrees. When we deal with arc addition postulate, we need to recognize that when we have adjacent arcs, those two arcs add up to be the larger arc. Does that make sense? So the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. I think it's kind of an obvious one, but it's a neat little postulate to hold on to. So with that postulate in mind, let's take a look at this one. We're going to find each measure in this particular circle. And as a matter of fact, we're not going to take a look at this. We'll do it in the next video. Let's take a breather, and then I'll come back and I'll pick up with example 4. Then we've got another little concept, and then we have example 5. So it should be short. All right, so I will see you all very shortly.